Today we're going to talk about set theory. And when we think about a set, think about it as a collection of something. So the definition of a set is basically a collection of distinct objects. Now, these objects could be anything. They could be numbers, they could be letters of the alphabet, they could be shapes of geometric figures, they could be colors, they could be anything that you want them to be. They could be a set of baseball cards, okay? So it's a collection. So if you are collecting a set of baseball cards, for example, then you have a set, you have a collection of cards, and every individual card in that set is an element, okay? So, the more elements you have, the larger the set's going to be. So in this class, we're going to talk about sets of numbers or letters and maybe some other objects, okay, as we go along. So anytime that we have a set, we use these braces that are in red over here to the right, these little squiggly lines. Those are called braces, and we represent a set. So an example is, let's say we have this, okay? We have a collection of numbers here. So we have a collection of numbers. More specifically, these are integers, because integers are positive and negative whole numbers, including 0. And we represent this collection using a set of braces, okay? And if we look inside this set of braces, right, and within this collection of integers, we have, if you count them, we have 1, 2, 3, 4, 5, 6, 7. So here we have 7 elements that make up this set, okay? So every individual number in this set is an individual element, okay? Another example of a set would be this, okay? Excuse me. Let's say you have shapes. Okay, maybe a square. Okay, within this set we have geometric figures. We have actually 4 figures, right? So we have 4 elements in this set. Okay, so a set could be anything you want it to be. It doesn't have to be numericals or variables. Like I said, it could be something simple as a set of baseball cards, or whatever it is you like to collect, a set of baseball hats, a set of rocks, whatever you want, whatever it is that you like to collect. It's a collection, okay? So that is the first thing that we want to make sure we understand, is what a set is and what set theory involves. And it's a little more involved, but this is the basic concept of what a set is and how it relates to elements, okay? So, so let's do an example, okay? We will write down this problem here, okay? And we will say the set of all even numbers. I would like you to represent that as a set using notation, right? So, all even numbers. Some examples of sets defined by listing the elements of that set. So, if you want to find the set of all even numbers, then think about all the even numbers that you can think of, okay? We can say, use a different color here. First even number would be, what, 2? And then 4, 6, 8, right? Okay. Of course, all even numbers go on into infinity, so, that's with the 3, the little dots there at the end indicating that this set goes on forever. The set of all even numbers, right? Start off at 2, 4, right? You can do the same thing with the set of all odd numbers, I mean, the first odd number is 1, and then 3, then 5, then 7, then 9, etc. Okay? Again, some sets can define a list of elements. So, if you say, I don't know, the first 3 even numbers, then you can say something like this. The first 3 would be what? 2, 4, 6, which is a defined set. Only has 3 elements because we're not including every single even number that's out there. So keep in mind that sets can be limited or restricted, but unless you see this notation with the 3 dots there. So again, you can have any set that represents any element. So we have, 4 elements here? No, this will actually 3 elements. This would be 3 elements. Okay, this is just an example, okay? Okay, so let's kind of move on to some notation, okay? When we say, when we use something that's an element, so let's say we have, let's talk about the notation here. Okay, we're going to use the symbol okay, and that means that it's an element of, okay, that's what that means, okay, so is an element of, okay. So any set that contains no elements, okay, let's say you had a set, right, and there's nothing inside the set, then that's called an empty set, okay? This is called an empty set because there's nothing inside, nothing representative at all, okay? No elements are represented, so that's an empty set, okay? You could also use this notation, okay? Just so you know, you can also use this notation, and circle with the line through it. That's also an indication of an empty set, okay? If you were to use braces, there shouldn't be anything in there, but this is the standard notation that you want to use right here, okay? So let's look at an example. Okay, and we're going to let A be representative of a set. 1, 2, 3, 4. And to note that something is an element of this set, let's pick the number 3, for example. To note that 3 is an element, then we just simply do this, okay? We would write 3, okay, is an element of set A. Don't forget, A is going to be representative of all these numbers here, okay? So instead of writing all of those numbers, we can just say set. We can assign that set a variable So we know that when we say set A is equal to 1, 2, 3, 4, we can just say 3 is an element of that set instead of writing all of those numbers. So it's a little bit easier, okay? So 3 is an element of A. Very simple, right? Okay. That is the first thing that we want to identify, okay? The other thing is that we can say something is a subset. Okay? And a subset of a set A is another set that contains only elements from set A, but may not contain all the elements of A. Okay? So, we want to make sure that we understand that. So we can say a subset of a set A is another set that contains only elements from the set A, but may not contain all the elements of A. Okay, a little wordy here, but it is what it is. It's just one of those definitions that we need to break down. So let me give you an example of this, okay, something a little bit more concrete. Let's use the notation. How do you write this using notation? Because I wrote this deliberately to show you how long it takes to write all this, right? So when we do set theory, we want to use symbols. We want to use notation so that we can kind of go through problems more efficiently. So how do you say if B is a subset of A? Well, we do this, okay? If B is a subset of A, then we write this. Kind of like a U that's on its side with a line under it. Okay, B is a subset of A. Okay, so that means that B is part of a larger group. A is going to be like a larger group, and then B is like a subset, a smaller set from that bigger set, if that makes any sense. And then another thing that you're going to keep in mind is that you're going to see a lot of this. It's called let me just underline this. Okay, so the first thing is a subset, right? That's the first thing, okay? And the other thing is called a proper subset. So a proper subset. All right, what does that mean? Okay. So it is a subset that is not identical to the original set. In other words, it contains fewer elements. Okay. How do you represent that in symbolic notation? Okay, so again, if B is a proper subset of A, then that will be written as follows. Okay, it's not the letter C, that's a U that's on its side. So make sure that we understand that. So again, a proper subset is a set that is not identical to the original set. It contains fewer elements. So if B is a subset of A, then B has fewer elements than its original set, which is A. So think of a subset as a smaller collection of something that's part of a bigger collection. So it should have fewer elements than the original set, if that makes any sense. Why don't we do an example? Examples do speak louder than words, I guess, in some cases, right? So let's go ahead and look at another example. Okay, we're going to consider 3 sets, okay? So we're going to call set A the set of all even numbers, and B is going to be 2, 4, and 6. C is going to equal these elements, 2, 3, 4, and 6. Okay, so in this case, all right, in this case here, B is going to be a proper subset of A. Okay, because B has fewer elements than A did. All right, A has the set of all even numbers, every single one of them. B only has 2, 4, 6. So B would be an example of a proper subset. Okay. Why? Because since every element of set B is also an even number, so we got to consider that too, right? Okay. So every element in set B is also an even number, okay? Because set A is the set of all even numbers, and if you look at set B, 2, 4, 6, those are also even numbers, okay? So since every element of B is also an even number, okay, so is an element of A. All right. Now, more formally, we would write this, right? More formally. So okay, we can say this, all right? We can say B is a proper subset of A, which we recently said a moment ago, right? Why? Well, it's because since if X is an element of B, then X is an element of A. Okay, and so, you know, you have B, that's a proper subset of A, because it has fewer elements. All right? Why? Because that's going to occur if X is an element of B, then X is also an element of A. Okay? So, you know, you see the three elements in set B are elements in set A. You can clearly see that 2, 4, 6 in set B is part of a larger group of numbers, larger group of even numbers. I got to remember even numbers, right? 2, 4, 6 is the only first few of them, right? First three of them. Well, all even numbers are every single one of them, so that's a larger set. Okay? That would be the formal notation. And then we can also say it's also true, okay? Also true for, also true that B is a proper subset of C, okay? Because C has more elements, B has fewer. Now again, interestingly enough, C cannot be a subset of A. Okay, does anyone know why? It's because C has an odd number there, and the original set did not mention anything about odd numbers. Okay, it's all even. So, as a extra piece of information, C is not a subset. It's a little difficult to write at the corner of this pad here, so I apologize, of A. Okay, and that's because of the 3. All right, that's an odd number. And there are no odd numbers when we talk about all even numbers, so that can never be a subset. Fails immediately. Okay, well, that's just a little crash course of set theory. I will have more videos that will give you more examples of this next time. Thank you so much for watching.